Today's lecture will be about advantages of eco-freeze refrigerants as compared to halogenated hydrocarbon refrigerants that have been widely used nowadays. The main advantages of eco-freeze refrigerants are shown in Chart 1. Let us first consider them briefly. The first advantage is a low cost of refrigerants, which is thanks to consisting of natural substances. The second advantage is high performance of refrigeration equipment that uses eco-freeze refrigerants in comparison with halocarbon refrigerants. The third advantage is related to low operating costs of refrigeration equipment using eco-freeze refrigerants. This is because energy consumption of such an equipment and costs associated with refrigerants will be lower than for similar systems operating based on halogenated hydrocarbons. The fourth advantage consists in environmental benefits of eco-freeze refrigerants. First of all, it is a low value of global warming potential of these substances compared to halogenated hydrocarbon refrigerants. The last, but not the least, advantage is high compatibility of eco-freeze refrigerants with the construction materials and compressor oils currently used in refrigerators. Let's consider these benefits in more detail now. The first advantage is the low cost of refrigerants. As you can see from Chart 2, eco-freeze refrigerants consists of hydrocarbons, and their cost of production compared to the cost of producing halogenated hydrocarbons is significantly lower. In addition, the second benefit of using eco-freeze refrigerants is that the amount of the refrigerant to charge a refrigerator is about 2 times lower than in the case with halogenated hydrocarbons. As you can see from Chart 2, according to different estimates, the mass of eco-freeze refrigerant makes around 40–55% of the charging mass in case of halogenated refrigerants. These two things explain the fact that the total cost of charge using eco-freeze refrigerants will be significantly lower than in the case of halogenated refrigerants. In addition, it should be taken into account that in accordance with the EU directive, it is mandatory to gradually phase out the production and implementation of halogenated refrigerants in the market. As you can see from Chart 3, the cost of halogenated refrigerants production has increased significantly over the past few years. For example, the cost of R404A increased 7 times, and that of R134A increased twofold. This trend is observed worldwide, and prices of halogenated refrigerants will only go up. At the same time, the cost of eco-freeze refrigerants consisting of hydrocarbon substances will not see a dramatic change over time, since their use is not regulated by the EU directive. Chart 4 shows that in the future, the consumption of hydrocarbon refrigerants, including eco-freeze refrigerants, will increase over time. It is likely that the use of hydrocarbon refrigerants will replace halogenated refrigerants. The second advantage of eco-freeze refrigerants is that they ensure high coefficient of performance in refrigerators as compared with halocarbons. Chart 5 represents a theoretical study of 3 refrigeration cycles when different substances are used as working medium, including hydrocarbons refrigerants. As can be seen from this chart, it is not quite possible to determine precisely the improvement in refrigerators' efficiency when using eco-freeze refrigerants compared to traditional halocarbons refrigerants, since the efficiency parameters of refrigerators will, to a significant degree, depend on the parameters of the refrigeration cycle. But, for instance, when analyzing the results, as can be seen from chart 6, R600 isobutane refrigerant, which is one of the components of eco-freeze refrigerants, ensures a higher coefficient of performance at a boiling point in the evaporator of 7.2 degrees Celsius, with a condensation temperature of 30 degrees Celsius, as compared to refrigerants R134A and R22. At the same time, with the same parameters of the cycle, the hydrocarbon refrigerant propane provides a lower coefficient of performance than for the HCFC refrigerants. But if we analyze the cycle of a lower temperature, at a boiling point -31.7 and a condensation temperature of 30 degrees, then R22 is more efficient than the hydrocarbon refrigerant propylene. At the same time, based on the analysis of data given on chart 6, which is only theoretical calculations, it may be concluded that hydrocarbon refrigerants have potential from energy efficiency point of view. Currently, a large number of studies were carried out on the use of hydrocarbon refrigerants, pure and mixed, in various types of refrigeration systems. Hydrocarbon refrigerants and their mixtures, such as eco-freeze refrigerants, are the most widespread in air conditioning systems and heat pumps for domestic use, automobile air conditioners, and household refrigerators. Chart 7 provides information on the result of experimental studies currently available on the use of mixed hydrocarbon refrigerants, such as eco-freeze refrigerants, in various types of refrigerating systems in comparison with the traditionally used halocarbon refrigerants, such as R134A, R22, R12. As can be seen from this chart, it is experimentally confirmed that when using mixed hydrocarbon refrigerants in various types of refrigerators, coefficient of performance was increased by up to 4.5 and 11%, depending on the refrigerant with which the experimental comparison was carried out. It clearly allows speaking about prospects of using eco-freeze refrigerants from the point of view of higher efficiency of refrigerators, given a proper selection of these refrigerants depending on the type of refrigeration equipment. Chart 8 presents the results of experimental studies on the use of mixed hydrocarbon refrigerants based on propane and a small amount of ethane in heat pumps when operating with two parameters of the refrigeration cycle. In this study, the value of ethane added to the refrigerant varied, and the coefficient of performance was experimentally determined. It is shown that the use of propane as a working medium leads to a significant increase in coefficient of performance in the equipment, compared with the use of a traditional working medium R22. Moreover, addition of small amounts of ethane caused worsening of the coefficient of performance as compared to using propane as a working medium with no ethane added. Therefore, we can conclude about the expediency of scientifically sound choice of the composition of mixed refrigerants used in various refrigerators to increase energy efficiency of the equipment. Therefore, the range of EcoFreeze products consists of several types of mixed refrigerants, which provide the highest energy efficiency for various applications. The next advantage of EcoFreeze refrigerants is their compatibility with all materials and mineral oils currently used in refrigeration equipment. It is known that the application of halogenated hydrocarbons was complicated by the introduction of new types of synthetic oils, which are difficult to operate and are quite expensive. The main advantage of EcoFreeze refrigerants is the possibility of using mineral compressor oils in refrigerators that have a lower cost than synthetic ones and are easier to use when operating the equipment itself. Basic information on the compatibility of refrigerants of different groups with mineral oils and construction materials is given in Chart 9. In addition to using mineral oils that are inexpensive and easy to use, another advantage of EcoFreeze refrigerants is that they are compatible with all construction materials currently used in refrigeration manufacturing, which can be seen from Chart 9. Currently, environmental issues come to the fore in comparison with economic and technological challenges in the field of refrigeration manufacturing and operation. Despite a widespread application of such halogenated refrigerants as R22, R134A, their use is subject to environmental requirements related to the necessity of reducing application of substances that contribute to global warming. As was said at the beginning of the lecture, the production of working media that have high global warming potential is restricted. Their price will only increase over time. Such restrictions have so far been adopted within the European Union, but a number of other countries are expected to adopt such restrictions in the future. Therefore, the search for and implementation of refrigerants with a low value of global warming potential is a promising task. Chart 10 shows the comparison of the global warming potential of three eco-freeze refrigerants that are alternatives to halogenated refrigerants. As can be seen from this chart, all eco-freeze refrigerants have a very low global warming potential of about 3 kg CO2 per 1 kg of substance. However, such a refrigerant as R22, which is now widely used, has a global warming potential of more than 1,500 CO2 per 1 kg of substance. In addition, R22 refrigerant's ozone depletion potential does not equal zero. The application of R22 refrigerant is regulated differently in different countries. In Europe, it has already been banned, and within the next decade, the use of R22 refrigerant will have to be phased out. Although refrigerants R134A and R32 have zero ozone depletion potential, but their global warming potential is quite high, which can be seen in chart 10. In view of the necessity to comply with environmental requirements set by legislative acts, it is expedient to search for alternatives to halogenated hydrocarbon refrigerants. Eco-freeze refrigerants, which have very low global warming potential, can be such an alternative. So, we have considered the main advantages of eco-freeze refrigerants associated with the low cost of refrigerants, high efficiency of refrigerators when using these refrigerants, excellent environmental performance, compatibility of these refrigerants with the main structural materials, and mineral oils currently used in refrigerators. Is it possible, therefore, to assert that eco-freeze refrigerants are at present the best alternative to replace halogenated hydrocarbon refrigerants? Chart 11 provides a schematic representation of the requirements that refrigerants have to satisfy. They include low global warming potential, zero ozone depletion potential, high efficiency when used in refrigerators, compatibility with various structural materials and mineral oils, the cost of refrigerants and operating costs achieved when using these refrigerants during the entire life cycle of the equipment, and safety. Eco-freeze refrigerants perfectly match all the requirements except for safety requirements. Based on ASHRAE classification shown in chart 12, eco-freeze refrigerants belong to class A3, indicating high flammability and fire hazard. At this, their main advantage, according to this classification, is non-toxicity. Therefore, when implementing eco-freeze refrigerants, it is very important to closely follow all the requirements and standards for the fire safety, both during transportation and storage of refrigerants, and during charging and operating equipment by ordinary consumers, and by specialists during maintenance and recharging the refrigeration equipment. Safety issues related to the use of eco-freeze refrigerants, as well as the amount of eco-freeze refrigerants required to charge various refrigeration equipment, will be discussed in the next lectures. Chart 13 includes reference materials used during the preparation of today's lecture. Thank you for your attention.